All right, absolute values, our final topic. So absolute value is technically the distance of a number from 0 on the number line in either dimension. That's why it's called, or either direction. That's why it's called absolute value, because we're not taking into account positiveness or negativeness, positivity or negativity. So, for example, these two numbers, -4 here and +4, have the same absolute value. They both have the absolute value of 4 because they're both 4 units, 4 numbers from the center, from 0 on the number line. So, they would have the same absolute value. And here we've marked here absolute value in absolute value signs. These vertical hash marks are how we mark that we're using the absolute value of some expression. So they have the same distance from 0, so they have the same absolute value, even though one was really negative and one was really positive. Right, so the absolute value of -4 becomes 4 because -4 is 4 units from 0. Likewise, the absolute value of 4 equals 4 because 4 is 4 units from 0. They both work the same. All right, so if you have the absolute value of x minus 2 equals 5, you can interpret it as 2 separate equations. Because this absolute value sign ultimately means that you're stripping the sign off of whatever's in there and turning it into a positive number, this is really x minus 2 equals 5, and it's also x minus 2 equals -5. So you can treat it as x equals 7 or x equals -3. And in both cases, 7 minus 2 is 5, the absolute value of 5 is 5. -3 minus 2 is -5, the absolute value of -5 is 5. So you can interpret it as 2 separate equations, and that makes life easier. So when absolute values contain inequalities, which we just covered, consider what is inside the absolute value markers to be over or under a certain distance from a midpoint. So, for example, the expression, the height of every basketball player falls within 9 inches from 78 inches. Okay, so the distance from some central value is within 9. So we would read that as the height, I guess we can make it h minus that central point. Whoa, why did I put a 6 there? Okay, let's try this again. Haha. All right. The height minus 78 is less than or equal to 9. So 9 is the maximum range from that central point that the height can vary. So the absolute value of the height minus 78 is 9. The distance from 78 inches is less than or equal to 9 inches. All right, let's do a little bit more. So you can solve these problems by, just as we solved an absolute value thing by writing it as 2 separate equations, we can also write it as 2 separate inequalities. So if we had, so this is continuing that same problem. We had the height minus 78 is less than or equal to 9. We could also write it as the height minus 78 is greater than or equal to -9. And so this is the only big trick here, is that, note, we had to switch the direction of the inequality. Because the difference between the height of the basketball player and 78 needs to be either at this, so we have our number line here, we have -9 here, +9 here. Because the range is from here to here inward, we had to reverse the direction. Well, you have to reverse the direction of the sign either way when you're doing this with inequalities. But otherwise, if we didn't reverse the direction of the sign, it would end up being greater than, it would end up being less than 9 and less than -9, which would not help us at all. It wouldn't make any sense. And so we can just treat these as 2 separate inequalities. This then becomes h is less than or equal to 97. 87, oh my gosh, okay. H is less than or equal to 87, and again we add 78 to both sides. H is greater than or equal to 69. So their height is greater than or equal to 69 inches and less than or equal to 87 inches. Again, giving us a range of 69 inches to 87 inches. If we hadn't reversed this second inequality sign, this would have come out to be nonsense. So that's how you do them. So here's a good example. If x over 4 is greater than 1, which of the following must be true? Select all that apply. So remember, we can treat that as two separate ones. X over 4 is greater than 1, or x over 4 is less than negative 1. So to multiply both sides times 4, x is greater than 4. Multiply both sides times 4, x is less than negative 4. Now in this case, our number line, if we have negative 4 here, and positive 4 here, and 0 here, our inequality goes off in opposite directions. Note that that can happen. That's totally normal. Some of them are just like that. So, don't freak out about that. So we have two possible ranges for x. We have x is greater than negative 4, x is less than, x is greater than 4, x is less than negative 4. Well, here's x is greater than 4, and it's definitely not x is less than 4. X can't possibly be equal to 4, because then 4 over 4 is 1. The absolute value of 1 is not greater than 1. So it can't be this one. In fact, it can be D, because we need x to not be equal to 4. Because if x is 4, this isn't true, and it says it's true right here. So this one must be true. Any number other than 4, this works. With 4 it doesn't, so x can't equal 4. And then finally we had our other possible value here. X is less than negative 4. So even though we only had two solutions here, you need to be on the lookout for other possible things that must be true. Had it been something like 4 over x, you might have expected in the answer choices x can't equal 0. So just be warned that they can sneak in more than one correct answer choice, even when there's only two solutions. They can sneak in more than two answer choices when there's two solutions.